Okay, here we have the baseball player A hits the baseball at 40 meters per second, 60 degrees to the horizontal. So let's assume we have a guy, a baseball player here, standing here. Let's call this guy A, and of course he's holding a ball. And he launches this ball at a velocity of 40 meters per second, and it is 60 degrees to the horizontal. So of course we already know that the ball will take a path that goes something like this. Okay, when the ball is directly above player B, so we have another player who is standing somewhere here. And this guy is B, and when this ball is directly above player B begins to run here with a velocity of VB. And we know that player B is exactly 50 meters from player A. So what we are required to do is to find VB and to find D. D is actually this distance here, at which B must run to catch the ball at the same horizontal level in which it was hit. So we are at the same horizontal level in which the ball was first launched. Okay, to find this, let us examine this question first by finding out the total time of flight that would take for the ball to go from here, launched, follow the path and lands here. Let's find the total time of flight. So to do this, we will start by saying S equals to ut plus half at squared, and since the ball lands, the ball begins to launch at this horizontal level and it lands at the same horizontal level, therefore the displacement in the y-axis will be 0. So if we analyze this from the y-axis, then Sy equals to uyt minus half gt squared. Since Sy is 0, uy will be 40 in this component, in the y component, the velocity will be 40 sine 60. So 0 equals to 40 sine 60 t minus half times 10 t squared. This is 40 times 0.866 t minus 5 t squared. 0. This is 0 equals to roughly 34.6 t minus 5 t squared. Therefore factorizing t, 34.6 minus 5 t equals to 0. So t equals to 34.6 divided by 5, which is roughly 6.92 seconds. So now we know that the ball would take exactly 6.92 seconds to move from this point, follow the path of trajectory and land back at its same horizontal level at the new point. Let's give this point's name. Let's call this point point 1 and let's call this point point 2. So the time taken for the ball to fly from point 1 to point 2 would be 6.92 seconds. In that 6.92 seconds, the range that is covered by the ball would be, again, S equals to ut plus half at squared. Since we're discussing range now, we would analyze it in the x direction. So xx equals to 40 cos 60 t plus 0, since ax is 0. So this term becomes 0. So Sx equals to 40, cos 60 is half, and t is 6.92 seconds. This gives you 20 times 6.92, which is roughly 139 meters. So we know this whole distance here, from the point in which the ball was launched from the point 1 to point 2 is 139 meters. Therefore, D would simply be 139 minus 50, which is 89 meters. So that solves for this part. Okay, for the first part of the question, actually, to find VB, which is the velocity in which this guy should actually run to catch this ball, the answer to that is simple, that this guy should actually run with the same horizontal velocity at which the ball is travelling. So since the ball is travelling at a constant horizontal velocity of 40 cos 60 degrees, this guy should also run at a constant horizontal velocity of 40 cos 60, or simply 20 meters per second to catch the ball at point 2. Thank you.